we're not that dirty today, so I'm not that worried. But and the reason you should check around the filament, is because if there's a loose piece of metal from one of these plates floating around here, and we turn the high voltage on, and it gets drawn up into there by the electric field, it can short across the two electrodes, and that will trigger a safety, and it won't turn on the high voltage. So it's best to keep that area clean as well. Okay. All right. So I think we're okay to start. So I'm going to close the door. Okay. Now I don't have to, I can use this to kind of secure it, but I don't want to crank it down. The vacuum's going to hold it shut. Okay. I just want this closed enough so that the pump can take over. Okay. So maybe a half turn or something after you get it closed there. And now that we're ready, remember the vacuum system is very easy. Just press start. Mechanical pump turns on, and in a moment the roughing valve will turn on, and we'll see this pressure start dropping. Okay, and when this pressure gets to the, starting to get to the higher vacuum range, the high vac valve will take over. The rough pump will stop. This will open, and then the ion gauge will turn on. And then at that point, you let it sit. You need to wait for probably at least 45 minutes, maybe an hour or more. Okay. If you want a very good vacuum, you see that there's a little burp of air, so it spikes the pressure and then it starts falling. If that doesn't start dropping, then there's probably still a crack. You can just push on the door and it'll catch and start pumping down.
Okay.
Occasionally the door doesn't seat perfectly, and you can just encourage it. So if you don't need to replace the crystal, it's best to put this back over here. And if you ever use the last one, or we get low or something, and you don't see more, usually I have 2 or 3 extras here. If you don't see more in here, let me know, and I'll come replace it. If you use the last piece of titanium, let me know, and I'll get us some more. Okay, and the rest of this is spare slides, and the rest of this is some extra hardware for mounting things. Okay? So... Now, if you were using the instrument by yourself, at this point, you would wait until you saw the high vacuum pump take over, and then you could leave. And the reason you should do that is because if there's an issue, you'll know, right? If you just press a button and walk away, you could come back 2 hours later, and it's still trying to pump down because the door didn't seal properly or something, right? So you should always pay attention and wait for this to happen. Once that happens, you can be done. Throw my trash away.
Okay.
Do you have a question?
I'm going to wait until...
Yeah, what will happen, so see this pressure keeps dropping, right? When this gets low enough, these will turn off and this will open. Okay, so these will go off and this will go on, and then this ion gauge will take over. Once that happens, it's going to slowly pump down to an even better vacuum. Okay, but you should wait, the 5 minutes that it takes it to get to that stage, because then you know it's doing what it's supposed to do, and you can come back later and do your evaporation.
Okay.
So we'll wait for that, and when that happens, we'll go over a couple of things in the guidebook, and then we'll start talking about the deposition monitor while we wait. So, because you can imagine this is some tricky bits to program a little bit. If you have to change something or whatever. And you're mostly going to evaporate what?
Aluminium.
And okay, so
iron.
I think there are some people in your group that do aluminum with some regularity. You should check with them. I think Daniel Hashim.
Yeah.
Yeah. So for one, and Li Hui is another. So check with them. I know that they've been doing it with the E-beam successfully, but I know they also are interested in transitioning to thermal for aluminum because it's a little more successful. The E-beam over time, the E-beam aluminum, the aluminum expands and it'll crack the graphite crucible that it sits in. It won't hurt the tool, but it'll, so you end up wasting. With thermal, there's less waste. And it works, it's less tricky to work. So it should take over very soon here. Right now we're at, 550 millitorr, right? When we get down to, 200 or 100 millitorr, this will take over. bring us very quickly down to the 10 to the minus 4 range, 10 to the minus 5 range. Should note on top there, you see the motor looking thing? There's a control for it on the wall. If for some reason you ever need to rotate or oscillate the stage, wobble it back and forth or something, that's possible, but it's not that useful. There's an upgrade they installed. I think one person used it a little bit one time. Daniel has used it. He showed me how when I took this job over last year. He was one of the few people I knew that knew how to do it, and it's very easy. So if you ever need to learn that, I can show you or he can show you. But it's also not commonly used. It might be important if you were doing something very thin over a large area, very slowly. That might be useful to account for any inhomogeneities in the source. But you're so far away. A heated or cooled stage would be more useful, I think, for some people. But we have a rotating stage, so. This is a set of reminders, very, very obvious things. Keeping the chamber clean. If you must use carbon tape, don't use excessive amounts. Clean the door seal. If you put resists in here, some people do photolithography and then they put a device in here to coat. Okay, you need to make sure the resists are baked, hard and not liquid, right? That'll make a mess of things. Use a crucible liner for almost every kind of source except titanium. Put your source in the correct location. We have a special assignment for gold, platinum, palladium, and aluminum. And then the magnetics go in 6. Iron, nickel, cobalt, occasionally.
What's this?
Other.
Okay.
Almost anything else. We have someone who does ITO. We have people who do aluminum oxide. We have silicon dioxide. Somebody does copper from time to time. They'll put it in 5. Okay. And this is just because a lot of people depend on this to make clean gold films. And so we want to make sure we don't pollute that with other things. So it's a shared instrument. We have to try to account for everybody. So one of the compensations is, okay, the magnetic guys get this one, all the weird stuff goes here, and then these very common things go here, here, and here. Now, several people do silver with some regularity. Silver's not really a problem. It works very easily. It's typically very clean. It's very controllable. And so some of them put it in 5, but occasionally they've had to do, I had someone who was doing copper and silver, and I told them they could put their silver here or here. Because I knew the material and I knew the user, and they were trying to, the copper I wanted here, and so we made a judgment call. So if something like that comes up, just talk to me about it. That's generally the answer is, talk to me and we'll figure out the best thing to do. What I don't want is people doing things, blindly without any input if it's not standard. So it's not a big deal. I'm available over the phone. And, if there's ever a question, I'd rather you guys call me, even if it's off hours on a weekend or something. If you're concerned that something is different than you expect and you're not sure how to proceed, I'd rather you call me than start punching buttons. You know what I mean? So, there you go. So we got below 200 millitorr. Okay. So that turned off, and that turned on. Pressure drops very rapidly. This gauge will cease to function well about now, and this will take over very shortly afterwards. It's not really good for the -4 range. It's trying, but it's not that accurate, so the ion gauge takes over, and that's housed underneath the instrument. The ion gauge, the glow tube thing. So, and at this point, if you were doing this by yourself, you could walk away. You'd be done until you're ready to come back and evaporate. So, now it depends on the user. You might want to program the thickness monitor and then leave, or you might want to come back and program it and do your evaporation. It's up to you. If you're doing this on your own today, we're only taking a couple of hours because it's training and it's titanium, which is very good for the vacuum system. So I know I don't have to wait for an excellent pressure for that, and I'm not coating a sample, right? But if you want a good quality film, I recommend letting it pump down at least a couple of hours, because after a couple of hours, you'll be in the -6 range. The maximum appointment time, unless you have some special concern and you've talked to me about it, is 4 hours. Okay, and so in 4 hours, you can prep the instrument. If you're experienced, you can do that in 10-15 minutes. Depending on how thick you need your material, you can do your evaporation in half an hour, 45 minutes. So you can have up to 3 hours of pump down time.
Yeah, okay.
And sometimes that will get you into the upper -7 range. Okay.
That's okay.
But for a lot of the work, especially if you're at the prototyping stage or something in your device, maybe you don't need the best film in the world. You know, I have some users who are, as they're developing their lithography pattern, their first couple of evaporations, they'll only pump down for an hour and a half because they just want something, you know, they can see under a microscope. They don't care about the quality, they're not going to test it. They're just looking at the pattern. Later, when they're making a real device, they'll pump down 3 hours before they evaporate, so that they have the best quality film. So, anyway, oh, hey, here's a good example. This is an old crystal. Someone left it out. You can see that's the part that's exposed to the chamber, and that little ring around the outside is what's covered by the holder. Okay? You shouldn't leave these here, but you also shouldn't throw them away because there's some valuable resources on them. So what we can do, tuck them up in the vacuum. Okay? Because eventually, I'll send that vacuum bag out for reclamation. And we'll get credit for everything that's in there. So and it keeps waste down, right? Just put them in there. Crystals are fun. Okay? All right, so I want to review this with you real quick. So this was you see the instrument, okay? This is one of the things that needs updating. There used to be this ugly gauge thing over here for the pressure, temperature of the cryopump. It was hard to read and stuff. Now we have this digital gauge, much nicer. Okay, so this is venting the chamber and prepping your sample and starting the pump down. All the things we just did. This is a reference that discusses all those details, right? And these are some, reminders about that too. Okay. And right here it basically says wait for the base pressure you want. Okay, so at that point we're ready to turn on the E-beam. Well, that's not going to happen for at least an hour. So we're going to wait. We're going to wait for an hour before we do anything. It's we have it till 9:30. We won't wait an hour. We'll wait like 45 minutes maybe. So, but we've got some stuff to talk about before that. So because we have this till 9:30, and it'll take us 20 minutes to do the evaporation.
Okay.
So because we don't need to put down much. This is a demonstration. So, all right. So now this source talks about setting this thing up, but it doesn't give you a bunch of details. So I want to kind of walk you through that. It's a little bit intuitive learning. Okay, so right now we're in what the status screen, okay? And this tells us that what happened last was someone stopped it, okay, at the end of their process, and they were doing film 2, which was gold. Okay. Also here. So this number only corresponds to these positions for these two things. Maybe for platinum. Everything else is based on number. Okay, so if I'm doing silver, it might be in location 5, but it's film number 8. Okay, so this number is less important than these numbers. All right. Okay, so and that's what it tells me. And the crystal is fine, and that's that's what it was. Okay, now we're not going to do gold or silver or whatever. We're going to do titanium. So what we want to do is change it so that we're going to tell the instrument we're ready to evaporate titanium, okay, and that's what should be happening next when we press start. Okay. We're not going to press start yet because we're not ready and none of the high voltage is on. But when we get ready, we want that to be the thing. So I press menu. Now it's a touch screen. I recommend using the touch pen here. This one doesn't like fingertips. Those are okay with fingertips. This one not so much. Okay, so these two, view film and next film, those are the ones you want to pay attention to. These guys are for maintenance. Okay, so review film, next film. Next film is what you're about to evaporate. Okay, you always want that to show you what you're about to evaporate. So we're going to do film 1, which is titanium. Okay, then you have BAK for back, ENT for enter. Enter. This is the current status of the instrument. Angstroms per second, percent power, how much deposition. If I press 0 to get rid of this, that should reset in a minute. Or not. Oh, I'm not on the status screen. All right, it doesn't reset here. I have to go back out. Anyway, note the angstroms per second rate. So that's 1/10 of a nanometer per second, right? And then kiloangstroms thickness. 1 kiloangstrom is 100 nanometers. It's a bit of a weird unit, so remember that. If you're doing 100 nanometers or something, you want this to read 1 kilo extra. If you're doing 10 nanometers, 0.1 kilo extras. Okay. Little confusing. All right, so that's great. We said the next film's titanium. This should be good to go. However, you should never trust that a shared instrument hasn't been messed with accidentally. Okay, so what we want to do is review the film. Because this is a pre-programmed film, it should have this density and this Z factor. Okay, but we need to check it. Now you can see the last film that got reviewed, edit film, was gold. Okay, 2. Edit 2, gold is 19.3 and the Z factor of 0.381. And the top 2 things are what you want. If I go up to the bottom of the sequence, we don't normally. It changes the top 2. Okay, density and Z factor. So you can push arrows until you see that. Now, we don't need to change gold. I could press buy and go back out, away, go back a menu. I could edit this if it was wrong, but this isn't the one I want. I want film 1, so I have to go to GO2 FLM, go to film number 1. Enter. Now we check. Titanium Z factor is 0.628 and density is 4.5. Lo and behold, they're correct. Okay, so someone didn't mess this up.
If it is not correct,
if it is not correct, you press edit. Yeah, exactly. Yeah. So edit, and it'll say, okay, 4.5, you want to go back or change it. You want to change it. 450, enter, go back. There it is.
Okay.
Right? Exactly. So you got it. That's it. So you check. If they're right, great. If they're not, fix them. Okay? And when you're done, press buy. Okay, so now we're back to the menu screen, and it'll say press status key for runtime, for active mode. Okay? Status. Right? Now if I want to zero this noise, okay, I can do that, and it goes away. Now you'll note something. We changed it to film 1, all that stuff. It says film 2. Okay? When it stopped, it shows the last thing that happened. Okay? When we're ready to start again, we'll press start a couple of times, and it'll reset it to film 1. Because we have set it to next film 1. Okay? So when you set the instrument up and you go back to the status screen and it doesn't show the film you want to do, don't worry, that's the last thing that happened. Okay? Until you press start again, it won't update. Okay. Right? So you can see we're already down to the mid-5s. At this point, we're going to wait. Okay? Do you have any other questions about the setup?
No.
It's pretty straightforward once you kind of learn what to do. And, you know, I've got a phone call to make because our DI water system is down. So I'm going to go make a phone call. If you want to hang out in here, you're welcome to. You can, you know, check things out on the thickness monitor if you want to, or you can take a break and get some coffee, whatever you feel like doing. We should meet back here at 45 minutes, so 10 minutes after 9, something like that.
Okay.
5 minutes after 9.
Okay.
Okay? I'm going to go, like I say, I got to go make a phone call to get our DI water